Hello everyone, you're watching AI Galaxy to the Guide, AI Guide to the Galaxy. My name is Oleg, I work with the Docker DevRel team, and I am super excited to invite our guest, Kevin Wittek, to the virtual stage. Today we're going to talk about a topic that is very, very timely and relevant in the current age of AI. We're going to talk about sandboxing AI agents. Hi Kevin, how are you doing?
Hey, I'm doing wonderful and looking much forward to talking to you today.
Awesome. I know that you're very, very passionate about sandboxing the outputs of and work of AI agents, because you are on the team at Docker who is dealing with just that. Can you maybe elaborate a little bit what you're doing and how you got there?
Yeah, I think I'm more passionate about not putting developers into virtual Skinner boxes where all what we do is basically end up with this reverse centaur where we are the ones saying enter, enter, enter to what the coding agent is doing. And sandboxes as a safety and potentially security technology is a way to contain the unwanted side effects such an agent might perform if we let it run by itself without any further permission schemes. And there are different variants what a sandbox could be and like how different people understand sandboxing. But in the context of coding agents specifically, we have seen currently in the industry that people understand a sandbox as either some kind of secure environment in which an agent itself can operate more safely and secure in a potentially more autonomous way, or sometimes a sandbox is also meant as a certain environment in which an agent can spawn and execute workload safely. So it sounds very similar, but like the difference is in the one example, the agent is running within the sandbox. In the other example, the agent is running somewhere else, maybe on a host even, and then using sandbox to executing his untrusted workloads. And we're working on both at Docker, to be honest.
Right, right. Yeah, I just want to say, just recently we announced this partnership with E2B about the sandboxes. And I think from your description, I understand that that is more an environment where your agent that can be run outside of the sandbox can operate and safely execute code, even though some samples there were putting the Claude Code, for example, or Gemini into the this cloud environment as well. So you're working on the project within Docker, the sandboxes recently announced. We have the documentation updates. This is where we encapsulate the AI agent within the Docker primitives, providing the context for isolation altogether, right? So it's sort of, if I would think about it as a dev container for AI, would it be wildly wrong, or is it sort of along the correct thinking?
I think conceptually that's really what we are aiming for. So very similar model than what dev containers wanted to be for IDEs to a certain degree, I would say. Now we are trying to do with, instead of having the IDE as a primary UI, we now have coding agents as the primary UI, and that's why those things now have also a little bit different shapes than what we had with dev containers. And maybe we can also make it stick now better than dev containers, because dev containers, while I always thought it was a cool idea, it never got like super broad adoption in the industry, right?
In my bubble, it haven't. But I know that I think the split was approximately maybe half and half for big enterprises, and people had very different opinions about the UX of dev containers, where some teams would be migrating towards dev containers, the other team would be migrating off dev containers to the sort of native hosting development environments. But let's talk about AI. So we are doing sandboxes, and E2B are doing sandboxes, and Cloudflare recently announced sandboxes, and everyone is doing sandboxes. It feels, in the last couple months, it feels like sandboxes are really like a very big point of investment of effort and time. Like, is it really like, is it really the most critical thing that is currently missing from AI? Is it such a big problem to run AI without a sandbox? Like, what's happening?
So I believe it has to do with the fact that the output or the performance of AI becomes better once we are reaching a realm of statistics. So what do I mean with this? If we let AI brute force more extremely and potentially more in parallel, we have a higher chance of eventually landing at the right solution. While if we just try to babysit one single agent reaching the right solution, it might just derail, right? And for using this architecture, which is basically using agents to brute force into a solution, we need some kind of mechanism to contain them, to allow them to operate autonomously. And sandboxes in the different flavors seem to be the missing piece that potentially unlocks it. And yeah, maybe to repeat myself from the beginning, I really want to avoid also a future where the main job of a developer is to sit in front of the computer and press the enter button to accept what the agent wants to do, right? So that's why I think running agents in a safe, secure way that allows them to run more autonomously will be very good for software engineering as a whole and the software developers.
Yeah, I agree. Even currently, I think the most productive teams start to shape where people just whisper into their microphones to tell AI what to do, and then sort of oversee the final outcomes rather than individual steps of how to achieving that. What is wrong with the normal? So like, I know Gemini, CLI, and I think Claude Code and Codex and everyone else, they all include some sort of sandboxing mechanism. Very often this uses, I think, Seatbelt on macOS for restricting both network and some local operations. And you can specify different policies. And maybe there are some other approaches. How is Sandboxes that we are working on at Docker, like your team is working the Docker Sandboxes, how is it different and why is it better? And where are we taking, like, where will area of like Seatbelt applicability stop and where the sandboxes will truly shine?
Yeah, so I mean, first of all, Seatbelt is macOS specific, so you need a different solution on every platform. On Linux, they might use something like Bubble Wrap, or on Windows, I don't even know what you would use there if there is like a similar technology, unless you put your application into a Windows Store app, which makes it so different. So, like, first of all, you don't get this parity across platforms, and then what those profiles do. And so you also have to get those profiles right? So macOS Seatbelt profiles are a lower level kind of technology that is, I think, from the API side from Apple actually deprecated, but not because they want to remove it, but because they don't want to have developers use it as a public API because it's so easy to get it wrong in certain details. But I'm not saying like the others are getting it wrong, right? Just saying like there's always a risk when using these lower level primitives directly. And what these configurations currently achieve, so they do the network security boundaries decently well, I would say. And also they do the restrictions on the file access and so on decently well, but also to a degree where they limit the autonomy of the agent significantly. What does this mean concretely? If you look at the Claude sandboxing implementation on macOS, it will sandbox the working directory, but to a degree where then the agent is not really allowed to use external tools. And that makes security-wise a lot of sense, because once you get access to external binaries, they not necessarily can work within the confines of that Seatbelt profile, or couldn't act there. So you cannot install other system-wide tools. You could not install compilers, SDKs, whatever you need. So those have to be still prepared by you manually. But on the other side, agents are pretty good actually in figuring out what has to be installed to make a project build, run, test, and so on. So we're losing now this capability. And then the UX of the coding agent has to drop to the user and say like, oh, I cannot run this command in the sandbox environment because I don't have access to these native tools. Do you give me the allowance to do it? So now you can say yes. Then you are again where we were before. You have to approve everything, or you accidentally say, oh, approve all, and now suddenly all kind of commands that have a certain shape of calling native, a certain native binary are allowed, and that now you implicitly put a hole into your sandbox. So with, on the other hand, now with the Docker approach we are following right now, which is not only container-based, but also uses a micro-VM as an additional isolation layer, we have already, through the isolation boundaries of this virtual machine, a pretty good guarantee what kind of file system side effects the agent can create, mainly only accessing the parts of the file system we somehow share with the virtual machine. And so networking wise, similarly, we restrict the network access of the virtual machine as a whole. So no matter what the agent does within the virtual machine, where it can actually run effectively as root and make any changes it wants, it has to go through this only network outbound connection that we control, where we can control the network policies. So it's just an easy architecture, I think, to reason about with regards to its security and safety guarantees. And that makes it also easier to get the UX right, and a powerful UX that enables and empowers developers.
Right. I like the simplicity because I'm not a security expert, but I think the more complex the solution is, the more possibilities are there to get different holes into it. Right. So I'm sold. Show me this goodness. How do I get this Docker sandbox experience with my coding agent?
Okay, so I'm going to show you now our current development build, and depending on when this episode will air, you will maybe be able to have a similar experience in your Docker desktop or not. But the current version I'm showing is already using the microVM implementation, where we're really in the middle of re-architecting things. So you will for sure see some rough edges here. All right, so I'm having here my terminal, and now my sandbox daemon is running. That's not something a user would see, right? That normally would be hosted as a process in Docker Desktop or somewhere, but it's cool to see later the logs on what is happening, and it's just how I run my development version. So I'm having here my own Sandbox D server, similar to how we have a Docker D server for running containers, right? But in this case, it's a server that will be able to spawn VMs. Or spawn sandboxes that run then in a microVM. And now as an example, I actually we can look here in the VS Code. I used a very old schoolish example that I don't know if people know this, but that's the Gilded Rose cutter. And I used to be very active in the software crafting community, and there you would do like TDD and cutters and whatever, these kind of things. And that's a legacy code cutter where you're presented with a legacy code base that is very, very messy, and then you are asked to change the implementation to add a new functionality or like a new requirement. And it's here available in many different languages. I thought, okay, like these kind of things, back then we would take 1-2 hours to do those things together in meetups. Let's see what happens if we just let the agent loose on this. Okay, so we have this Gilded Rose cutter, and we will have here a Go project, and it simulates kind of a shop, and like
You need a COBOL.
we could have seriously checked the COBOL, but I haven't tried out. So we will do the Go one because I have a prompt that I know will lead us to good solutions. So we have here very, very messy code with many for loops, nested if else, and so on. Very, very messy. And then we have this requirements that here says, okay, you have items, they degrade in quality, then their value changes, yada, yada, yada. So the actual task at hand here is not that important. We just want to see how it looks like once we put an agent on it. So I'm now in this directory with all the programming languages, basically, and I'm now starting my Docker sandbox. So I'm now having this Docker sandbox run VM command, and I say run VM Claude. And now this is starting a microVM very transparently, right? And in this microVM, we will start an additional Docker container that will then be my application. in this case Claude, and we will also transparently bind mount the current working directory into it so you get access to it. And now we are presented with this dialog. And as you note now, you are not presented with the question for authentication. Why is that? It's because if we look now what the daemon is doing here on the side, we see a couple of log lines here injecting credentials. So we build a secret injection mechanism by which we inject the entrophic key, in this case, from your host into the HTTP requests that are outgoing from the VM. So the cool thing is the agent never gets access to my API key. So it could also not leak it. And that, of course, would also work for other API keys or other keys I would need to authenticate against other external services, this mechanism. Okay, so now we are here in Claude, as people know it, and I have now prepared a nice prompt.
Sorry, that's interesting. So if my agent will just send the a request to, for example, api.anthropic written with Cyrillic letters, we will not inject the API key. Or are we just adding API keys to everything anyhow?
Oh, we will. We basically set the so we check the destination of an HTTP request, and then we inject the authentication header.
Right.
That's what we basically do. Yeah. Okay, so I have here now a prompt prepared to solve this kata for Go, and let's look at it. So this project is the Gilded Rose coding kata. We want to solve it now for Go using TDD styles. All files we want to work on are in Go, in the Go directory. Check the requirements MD for the software requirements. Use a TDD by requirements approach to ensure you have a test harness for the current functionality before making any changes. So aim for 100% test coverage. Ensure you write good tests by using mutation testing. Use an external dependency, Gremlin, for mutation testing. Also make sure the test fixture continues to work for any change you make. Work autonomously using the test until you implement all new requirements. Anything still unclear. All right, and we fire this off, and then let's see.
Right, while it's working, if you say credentials are injected automatically, which providers are supported? Or is it possible to customize, or the Windows?
It will eventually be possible to customize it. Right now, the in this current implementation, development implementation, the main coding agent model providers are supported. So OpenAI, Gemini, Claude, and whatever, right? So the list is growing and growing. It's just basically a list of mappings of which URLs and which authentication headers. That's how it works. Okay, so it asks, shall I proceed autonomously? Interesting. When I did this example the first time, it by itself did already proceed autonomously. This time it asks me. So we just say yes. Okay, and so it's running now as a default in bypass all permissions mode, as we can see, how some call it YOLO mode, which is good because that's what we want to have, right? We want to run it autonomously, run the test itself, install necessary dependencies, and that's what eventually we will see happening here. So it's writing tests, and now if people are wondering, okay, how do I inspect these changes? How do I know what is actually happening? Of course, you can always ask Claude about the diff and so on, right? That's also possible. But at the same time, we can also just check. So there aren't any changes yet. But like once the changes appear, we will see them here from our host in Visual Studio Code that has the same directory open since we have this bind mount against the host. Right, now things are happening. So now we see like the tests are here popping up. And that's indeed the workflow I tend to use. So I let the agent do all the changes in its sandbox until it believes it reached a halting state, a working state. And then I like to just use the tools on my host, like in this case Visual Studio Code, to check the diff, to then still commit things by hand. I mean, it depends on the use case. Sometimes you lie. It's nice if the agent actually starts to commit and push. Sometimes it's a bit scary, but very often it can be nice to, as a human developer, explicitly review and commit things, and you have a very nice synchronization step there. Okay, now we see, for example, it started writing the test, right? Now it wants to start the mutation testing. Now it needs to install additional dependencies like this Go gremlin, and it can just do all these things. And I couldn't care less what it does, because it's not polluting my host in any way. If I don't like what it do, if it trashes the system somehow, I just throw away the sandbox and start in a new one. So I have a lot of confidence to just let the agent run loose, and that's something that connects my history in developer experience to some degree. Like back then, I did test containers, and I was always interested in providing confidence to developers. They should be confident thanks to their tests, right? And now I want developers to be confident that they can just let the agent run loose on their code base, so to say.
Right. We have another question in chat. How big is the overhead with using the sandboxes? Is it just like a container, or
it's more than a container, since we have to run a Linux kernel? So it's a minimized virtual machine. That's only purpose really is to run Docker containers within. But I cannot give you any numbers with regards to the overhead. It's basically lower than the overhead of running the VM of Docker Desktop, but it's technologically also very similar than the virtual machine we have in Docker Desktop, which is also a very, very small virtual machine, right? Yeah.
Okay, so it's comparable. Could be comparable, right? We mount the current working directory into the sandbox. Do we mount anything else? Do we provide access to sort of like, if I'm using Claude Code, does my agent get my host machine Claude configuration files, like system-wide CloudMD, and maybe the configuration files for MCP tools and other settings? Or do I need to, every time I create a new sandbox, or every time I run my agent, right? Do I need to re-enter those details in configuration settings again and again and again?
Yeah, so the honest answer is I'm not sure. So it's not something we haven't really worked out yet, also with regards to the design. Obviously, you don't want to reconfigure things all the time, right? At the same time, I'm not sure if it's really sensible to just import or synchronize what you have on the host, because the requirements might be just different within the context of the sandboxes. So I'm personally not yet sure what will be the ideal user experience. What I know, what we will have to provide is some kind of persistence for the configuration within the context of the sandboxes, right? Obviously, you don't want to reconfigure it. And there we have to also think, okay, semantically, at which point do you want to reuse sandboxes also with a certain state? For the same project, very, very surely. Across different projects, again, I'm not so sure yet. And since already Claude provides this hierarchical way of configuring some things like the Claude MD, right? It's a bit like challenging to think through this whenever you have different hierarchies of configuration systems that kind of get merged to one. Okay, which things are system-wide, which are project-wide, how should we deal persistence there? So I think it's a bit tricky to get it right, but we really want to get this right. That's why we cannot give you a clear answer right now.
Right. Okie dokie. I understand. So another question from the chat. Is the microVM supported on Windows as well? And if it is, how, if you can share that?
So it's supported even on Linux. On Linux independent of Docker Desktop. And we are using effectively libkrun for this. And that is the same technology we are also using in Docker Desktop when you're using the Docker VMM hypervisor for the virtual machine. So we are actually building, like here on shoulders of, we're standing on shoulders of giants, right? The giants being what the team at Docker, our colleagues, already implemented for Docker Desktop, right? So we can reapply these learnings for maintaining a cross-platform Docker runtime environment.
Yeah. Okay, so there shouldn't be particular platform limitations like Windows or Windows plus WSL and or like ARM machines. All that we should get by extending
we
the
will
shoulders
see.
of giants, right?
We will see. So I know Windows, definitely Windows 11 is a requirement. So
Right.
Windows 10 wouldn't work, but I think it's also end of life for some time now. We are currently focusing on macOS ARM, and then on the second step would be Windows on AMD 64 architecture. So that are our current priority targets. But on the side, we already have it running on CI on Linux.
Right.
And yeah.
Makes sense. Right. So we've talked about the implementation or the developer experience of using this, giving it the freedom to run and run your sandbox as it wants, overseeing the outputs. Talked a little bit about the configuration. What else did I want to ask? I had a question about the locality of this, right? So obviously we are Docker, so we are building this into the Docker products and technologies, which I think is the correct spot for the sandboxes to be, because as you said, we are building on the existing technologies that are there. Would you, and this could be a personal opinion, it doesn't have to be the Docker's stance on this, do you think this could be a very beneficial thing to add into the implementation of actual agentic coding agents, right? So could Qwen code or open code, should they maybe like think and adopt some of that and be like running this by default or running this very, very easily with just some dash options? Or is it really like, does it really need like Docker's full support? So we need to control all the entry points and all the implementations around.
Yeah, I guess it would be more beneficial for the ecosystem if the vendors would decide to integrate themselves, actually. And then it becomes the industry de facto standard to run coding agents like this. So for me, that is a better story. But for driving the technology and also the UX, it just makes sense for us to start from where we control the UI, and that is a Docker command. That is by just wrapping the agents. But in practice, we are really interested in potentially having the agent vendors integrate from their side directly. We have to figure out the architecture a bit, or either way, definitely work together and collaborate with them on getting a good experience for their agents within our Docker sandbox command.
All right, awesome. Yeah, this is pretty cool. I've seen sandboxes and I've tried the initial implementation container-based sandboxes. That was cool. Now this demo with the a microVM-based approach, slightly different. I feel that it provides more confidence. So I would, even though I'm not a security person who say like, oh, containers are not secure and that my agent can escape that, somehow knowing that there is like a VM boundary around that, it feels more powerful. So I like that very, very much. What else is cool?
I mean, we can try the following, and let's see how it works out. Now I say, so it finished it in Go, right? Now I say, now do the same for the Java project. And I can say what I expected to happen, right? So I know the container image in which we are running doesn't have Java installed. So it has to somehow install Java first. Let's see what happens. I can share another detail. So we already have now a network firewall configuration built into this microVM, and you can just configure what domains are allowed, which domains are blocked. IPs and so on to give you like the real security guarantees around this. And I did the following. I just put ubuntu.com as a block domain. So now what we are generally expecting is that the agent would maybe first try to install Java from the Ubuntu repositories, and it should get blocked if everything works as I expect. So let's see. And then at one point we would see here output of blocked network access. So what it's doing, so it's currently still reading Java code and thinking about the implementation. So it's not yet thinking about running it. But once it starts to run it, we should see it understanding that it needs Java installed and hopefully run into some of our security boundaries here.
Right. While it is thinking, let me ask you a question from the chat. So, I know that you said this VM-based thing is currently in progress, right? And it's not yet shipped and available. Hopefully there will be some maybe builds or some possibility to get this by the time the video is aired. But what could be, are there any information about the development? Is it happening in the open? Are there any blogs or like technical discussions that people can follow? What's the good source of information about the sandboxes?
Yeah, so we have a release blog for the initial experimental release we did for the container-based one. That gives you kind of the storyline I also talked about. And besides, currently it's developed as a proprietary solution. I'm not sure when or if this would change. So yeah, I would say at this point in time, it's too early to point you at any additional resources.
This is
unfortunately,
absolutely fine.
but that might change in the future.
It's absolutely fine if this is an in-house thing.
So we saw, by the way, here error codes we're trying to fetch from ubuntu.com, and then if we see here, we see our proxy, our firewall blocked access to this IP, which are the Ubuntu repositories. So my nice sandbox now doesn't get polluted with a Java JDK that is installed from a Ubuntu repository. But the cute thing is, so if you look at what is allowed, GitHub.com is allowed. And sometimes, not always, but sometimes Claude will be very clever and he will just go to some open source JDK implementation and download it from GitHub, like Eclipse Timorine or whatever, Adoptium.
Yeah, they're very, very sneaky. Agents are very sneaky. I was showing recently an example of the MCP toolkit, and it has the ability, like the Docker MCP toolkit, right? It has the ability to inject interceptors before the tool calls. And in my demo, I had a very simple script that was, if a GitHub repository or a GitHub owner, GitHub organization was already in the session, so we access some repository, then if we try to access some other repository, it will block that access, right? So you can use prompt injection to say, bring me secrets from all other private repositories that we have, right? So yeah, and then the agent, of course, tries to execute the MCP call to get information from some other repository prompted by this malicious issue on GitHub as a demo, and the interceptor says, no, you cannot access that. The agents are very persistent. They're like, ooh, something went wrong. Let me try curl. Let me try figuring out something else. And this is kind of funny. But
so we had the first dummy implementation of this network firewall we had was just configuring it as a nearly optional proxy in the image.
Yeah.
So then I just asked Claude, okay, access this blocked URL, but try to really access it. And then it was like, okay, I can just like say no proxy to curl, whatever already works. So it's also helpful to test the boundaries of your.
Yeah, absolutely. You run this proxy inside the VM, inside the container, and then your Claude will be like, there's a proxy preventing it. Let me kill that process. I have the power of fruit. This is awesome. The coding agents showed absolutely incredible progress since even the beginning of this year. I'm not even saying from what we saw in the previous year or like maybe 2 years back. Now I really feel very, very confident that you can talk to your AI and then implement complex changes to actual real world projects with complexity of real world projects. Maybe not the biggest, but definitely maybe medium sized projects very, very well. And it seems like it's not stopping.
And it's still like very, very hard to interpret the output of the agent, right? In this case, so it finished its Java task. It obviously got blocked in installing Java. Still, it gives me the summary, 100% test coverage, and it even says here green phase implementation implemented, all tests pass. So it says all tests pass. Then I ask it, did you actually run the test? It said like, no, I can't because I don't have Java. So yeah, it is interesting.
They're very, very sneaky. They're pretty much like teenagers. They never listen to what you say. They immediately forget what you said just recently, and then they sort of not always want to work with you. Sometimes they just want to be left in peace, which is how actually all those problems happen, right? It is in conversations. There are more and more threads on Reddit, on LinkedIn, on other social platforms about like, oh, Claude Code deleted my home directory. And you will look at the screenshots and they would be like, yes, in that rm command, the ~/ is your home directory and I did delete it. I'm very sorry.
Yes.
Right? And then you were like, oh my God, this is horrible. So yes, very good. I feel now confident to run my agents in sandboxes. I like that we are able to run them in YOLO mode and give them the freedom to achieve the tasks that we give them as much as they want. This was very, very interesting to see in action based on the microVM. Thank you so much for coming. And I think this is it for today. Check out Docker Sandboxes. Don't let your AI delete your home directories, and stay safe out there.
Thank you. Bye-bye.